Welcome to the lecture series of Mechanics of Machine, and today the topic of discussion is V-open belt. V-belt and the groove of the pulley where it is mounted on share a similar type of shape, which is the trapezoidal. So here's the cross section of V-belt, and you can easily see it has a trapezoidal shape. Similarly, the groove of the pulley, if we close the top, then it will have a trapezoidal cross section as well. So most of the terminologies that are used in the V-belt are similar to the flat open belt, such as T1 is the tension in the tight side, T2 tension in the slack side, theta is the wrap angle, mu the coefficient of friction between belt and pulley. The additional angle is the groove angle, which is represented by beta. So the full groove angle, as you can see here, has a total dimension of 2 beta, whereas half of the groove angle, just like this, will have a angle equal to beta. So half beta sum up into 2 beta. So because of this configuration, the ratio of tension in the V-belt is slightly changed from the flat open belt. So in case of V-belt, the ratio of tension T1 to T2 is equivalent to e raised to power mu by sine beta into the wrap angle theta. So here is the critical difference between flat open belt and the V-belt. The remaining terminologies of flat open belt and the V-belt are very much similar. So to proceed further, let's see an example, and let's hope for the best that we can get some useful results from the example. So the statement of example that we are going to solve is: the electric motor drives a pump to transmit 50 kilonewton by V-belt. The RPM of driver and driven pulleys are 1000 and 300 RPM. This means the RPM of driver pulley is 1000 and the RPM of driven pulley is 300 RPM. The diameter of driven pulley is 0.75 meter, and center to center distance from the driver to driven pulley is 2.5 meter. Similarly, the groove angle of V-belt is 50 degree. So this is the groove angle 2 beta. So beta will be equal to half of this, which will be 25 degree, and coefficient friction between belt and pulley is 0.3. The maximum allowable tensile stress of V-belt is 3 megapascal. If the stress is more than 3 megapascal, then definitely the V-belt will break. Weight and speed of single V-belt are 0.4 kg and 20 meter per second. Means the V-belt as a whole, if we measure the weight of V-belt, it will be about 0.4 kg, and this V-belt is running over both the pulleys at the speed of 20 meter per second. Cross section area of V-belt is, this cross sectional area of V-belt is 400 millimeter square. And what is required? What will be the required number of belts to transmit power from motor to the pump? So here is the plenty of data that we have got, and the requirement is what will be the number of belts that will be mounted over the driver and driven pulley to transmit how much power? 50 kilonewton from the driver to the driven, from the driver motor to the driven pump. So let's do some calculation. For the ease, I made an Excel sheet, and let's discuss the Excel sheet in the next slide. So here is the Excel sheet. first the given data. The RPM of driver pulley is given, which is N1 1000 RPM. The RPM of driven pulley N2 is given 300 RPM. The diameter of driven pulley is given 0.75 meter. The groove angle was 50 degree, which was corresponding to 2 beta. So half of the groove angle, the beta, is equal to 25 degrees. Center to center distance from driver to driven pulley is 2.5 meter. Maximum allowable stress is 3 megapascal. Total power transmitted from the driver motor to the driven pump shall be 50 kilonewton. Weight of single belt is corresponding to 0.4 kg. The belt speed is 20 meter per second. The belt cross section area is transformed into meter square, which is equivalent to 0.0004. The coefficient of friction is 0.3. What is the required data? The basic required data is the number of V belts that we have to find it out, but there are so many other terms that we have to first find. If we know the diameter of driver pulley, which is unknown, the wrap angle theta, the alpha, tension at tight side, tension at the slack side, and the centrifugal tension, if we know these terms, then we can find the number of V belts that can satisfy the power transmission, which is the 50 kilonewton from the motor to the compressor. So how many belts that are required on the pulleys? Because if you have seen these drives where motor drive the pump or compressor or some other assembly, then normally if the power is much more like just as 50 kilonewton, then there are multiple grooves on the pulleys. This means the multiple groove, you have to mount multiple belts over the pulleys. So not a single belt, but the multiple belt can solve this issue of transmitting heavy power from driver motor to the driven pump. So how we can solve this problem? The first thing that we can have is the centrifugal tension. The formula is same as we have seen in the previous lecture, which is product of mass into square of velocity. The mass of belt is 0.4, whereas square of velocity, let's find where's here's the velocity. So you have to multiply 20 into 20 and then multiply this, the product of 20 into 20 into 0.4. So square of velocity into the mass, we will get 160 Newton. Next term is the T max. It's also taken from the previous lecture. T max is equal to product of stress into the area. So stress is here, the 3 megapascal, and area of the belt is 0.0004 meter square. If we multiply both of them, we will get 1200 Newton. The third formula, T1 is equal to T max minus Tc, is also taken from the previous lecture. It's nothing new, just subtract 1200, 160, subtract 160 from 1200, we will get 1040. The fourth thing that we have to find it out is the diameter of driver pulley. The diameter of driven pulley is given, the RPM of driven and RPM of driver pulleys are given. All these are known, so just put the values, divide the RPMs and multiply to the diameter of driven pulley, we will get 0.225 meter. Here we can check that our results are reliable or not. There is a very unique relationship between driver and driven pulleys. What is the relationship? Here you can see the RPM of driver pulley is more than RPM of the driven pulley. This means or you can expect that the diameter of driver and the driven pulley will be opposite to the RPMs. For example, if the RPM of driver pulley is 1000 and the RPM of driven pulley is 300, then you expect the diameter of driver pulley will be less than the diameter of the driven pulley. So let's see what we have got. The diameter of driven pulley is 0.75 and the diameter of driver pulley is 0.225. So this 0.225 is less than 0.75. This means our results are very much reliable because the RPMs and the diameters, they are opposite to each other. If diameter is more, then RPM will be less. If diameter is small, then RPM will be more. So we can say that our results are very much reliable. The next term that we have to find is the angle alpha. Very similar formula that we have used for the previous lecture for the flat open belt. We have used the same formula, and the answer was is 6.03 degrees. The angle theta, the wrap angle of the driver pulley is pi minus 2 alpha. So here we have the answer in degrees. It's converted into a radian. The thing that is new for us is sine beta. So it's half of the groove angle. So sine beta is equal to 0.42 degrees. The formula of the ratio of the tensions, T2 by T1 by T2 is equal to e raised to power mu by sine alpha sine beta into theta. So T1 is known, mu is known, beta is known now, theta angle is known. The only unknown is left is T2, the tension at the slack side. So we have to find it out. All the things are known. Just put the values and you will get 130 Newton. Again we have a check. We know that the tension in the slack side for most of the time it will be higher than the tension at the slack side. So tension of this tight side will be higher than the tension at the slack side. So can we see that? Yeah, tension at the tight side is 1040 Newton, where tension at the slack side is 130 Newton. So tension at the tight side is very much higher than the tension in the slack side. So again we can say that our results are very much reliable. Oh yeah, the next thing that we have to find is the power transmitted by a single belt. Most of the terminologies are known now. T1 minus T2, they are known. Subtract this value and multiply with the V, the velocity. What we will get? 18,204 watts. So to find how many belts that are required to transmit 50 kilonewton from the driver motor to the driven pump, what we can do, just divide this total transmitted power by this power transmitted by a single belt. By dividing this total power, which is the 50 kilonewton or 500,000, so if we divide this 50,000 by this 18204, what we will get? Here's the formula, 2.7. But this 2.7 is the unrealistic number, because if you count the belts it will be 1 2 3 4 5 6 7. It will never be like 1.2 1.3 1.4. You can count as numbers 1 2 3 4. So the nearest number is, because if the point exceeds, like if it's even 2.1 or 2.9, you have to use 3 belts. So to transmit power of 50 kilonewton, you will need how many belts? 3 belts. So 3 groove pulley of the driver shaft, 3 groove pulley of the driven shaft. So you have to mount 3 V belts over them, and then you can easily transmit 15 kilonewton of power from the driver motor to the driven pump. So here is our answer. If you have any type of question, then please let me know. I already uploaded this Excel sheet in the Google Classroom, so you can scroll through all the terms and you can easily see how I made the calculations. So in case of any questions, then please ask any type of question or any type of confusion you have got. So here's all. Thank you for paying attention.